So guys, hi to everyone. So this session will be in a little bit different format. So as I'm just explaining our missed title, so this lecture you can watch in any time. So there is no requirements that you have to be online, or if you have the free time, you can always so you can be online and ask the questions at the end of this lecture. For other students who are watching this video um, not online. So I mean, after saving that video, so all of your questions, you have to take them as a list and discuss them during the practice lesson with your assistant. And after that, if you didn't get enough answer for your questions, in that case, you can contact me in Teams, so using the direct message. And after that, if there is a requirements, so in that case, we will just call and one by one, face to face, we'll discuss your questions, and I will try to answer for all of them. So, so just a second. So today we have to just a second. Today we have to just continue learning the STL libraries that we started in the previous week. So STL, and in that week we discussed about the vector, sense, and map. So today we want to talk about the stack, queue, and the queue. So the stack, the queue, and the queue, they are also the collections of the STL that are already implemented, and you can just use them for your problems if there is no restrictions in the problem statements. Okay, the stack, queue, and the queue. So we will start from the stack. So about the stack, we already discussed in the previous 2 weeks. So stack, it's a strategy of it's a container that will be vertical. You can think about it like a vertical box. So the strategy of the stack, it's a LIFO, which means last in, first out. So this one is just a strategy of the stack. So about it, we already discussed. So you can think about it like, so let's put it over here. So you can put it like a vertical box, and in that box there might be some data. So again, for using that collections, like the previous week collections, you have to import them. So you have to include, so the library name also will be just the name of the collection. It's just a stack, so pay attention that S is using the lowercase. So after importing that, you can create the stack. So the creation of all of the collections, they are almost similar. So that just you have to put the needed collection. So it might be the vector, it might be the map or set or stack and so on. And you have to specify the data type, which data type you want to store in that collection. In our case, it's just the integer, and the name of the variable, it's a S. So again, if you have questions, guys, I see that some of you or you have the free times, and in that case, you can be online here. Okay, if you have questions, please take a note. So creation of the stack will be just the same as other collections. So we have, again, very similar functions that we already discussed from the vector, map, or set. So all of that, almost all of the functions will be available in the stack, but there might be a little bit difference. So for instance, for adding the new data to the stack, you can use a function push. So if you remember, we have the push back function in the vector. So this one is just a stack. That's why we have here the push to. In that case, a compiler will take our S. This one, let's imagine that this one is our empty stack. So this line, and 2 will be put it from the top, and it becomes in this position. And we're adding the new data like a 10. So 10 will be added from the top and 10 will be occurred on here. Again, we'll continue adding a little bit of 5. So 5 will be over here. And after that, we want to see the size of the stack. So about the size, you already again know that we have the function size, which will return the number of elements in that collection. It doesn't matter which collection I'm using. So I'm using this stack, and inside of the stack, I have the 3 elements. Again, we have the other function like empty. So this function is a Boolean function, if you remember, which will return true or false. Empty returns 1 if your stack is empty. It will return the 0, which means false, if your stack has any data, at least one item. So as you can see, we have here the 0, which means false, which means our stack is not empty. So for getting the data from the stack, you can use a function pop. So we have the 2 functions here. The first one is function top. So the function top, so again, I'm just putting showing the size. Showing the size of the stack, and after that I'm calling the function top. So by the name it can be clear and you can guess what will be the output. And it says the size is 3 and top returns the 5. So 5 means last added item. So last added item, which is over here in the top of our stack, will be returned. So after the top, if you call this size function again, in that case you will have the same result. So which means top function will take and return the value of the top position of the stack, but without any removing. So comparing with the function which called pop. So comparing with the pop, so pop will just not return anything. So it's just a void function. Pop function will take the first argument of the stack, so which means the top argument of the stack, and will remove it. So as you can see, we have here the size of the stack. Here we have the 3 elements. I'm calling it pop, which means it will just take and remove the 5. And after that, our stack will have the 2 arguments. So the 2 elements inside it. So as you can see here, we have this size 2. So comparing with the top and pop, top returns the first element from the top. Pop will take the first element and remove it. So there is a difference between these 2 functions. So all other functions you can also read by yourself if you need. So basically for solving the problems, so this type of the functions will be enough for manipulating data inside of the stack. So here we have the empty, size, push, pop element, and here I have the example of the brackets validation. So let's take and copy. So let's take and copy here. So this 2CVP and putting the results here. So question here is, so let's put a 5, let it be again a 1. So I'm pushing here the 1. I'm pushing here the 1. And question is, how can I show the content of the stack? So not using the indexes, or so we don't have any indexes because we have the we have here the stack. So that's why. So you can take and every time you can take the top to show the element of the top element of the stack, and after that remove it. Again, you can call it and remove it. So if you run it, it will return the numbers 1 and 5, as you can see. So the top function will return the first element, which is the 1, and pop will remove it. This one will return the 5, and this line will remove it. And you can do these operations inside of the loop, and in that case, you will just have the loop over your stack. So when you have to stop your iteration, and you can guess, so when you don't have any data inside of the stack, in that case, you can stop it. So which means while our stack empty returns false, which means our stack is not empty. So as empty will return the false. In that case, we will continue doing something. So what we are doing such like a thing. So we will just show the top element, put the space between it, and we'll take the pop. So I'm showing the current element and removing it, what we did in the previous example. And I think that's it for for showing the content. So after that, as you can see, the 1, 5, 10, and 2. 1, 5, 10, and 2. So like this, you can using the while loop, you can using the for loop, it doesn't matter. You can loop over your stack. Okay, it's time to the example that we discussed, that we announced in the previous nodes. So the example is, example is brackets validation. It's a version 1. Not version 1, let it be just brackets validation. So brackets validation is just a common task that might be in any lab work. So it might be in your lab works again. So now we want to discuss it. So let's remove everything here because we're just starting the new task. So the task is like this. You're given a one line. So not line, you are given a one string. So input. So it might be, input might be the different format. So for the simplicity, for the first task at the starting point, we will work using the parentheses. So you're given one string without any spaces, and your string will contain only the opening and closing parentheses. So it doesn't matter how many elements we have inside of the string. So there is a rule that we don't have any spaces inside it, and we have only opening and closing parentheses. And depending on the mathematical logic, so as a student, you know that this one is correct. This one is correct. This one is correct, but this one is not correct. This one is not correct by the logic. Logically, this one is not correct, isn't it? So our task is we have to identify can we write such like an expression? So this one is just a simple one. So let's do it like this. So you're given one line, so the one string. In that string, you have the mathematical expression, and your task is check the elements, so that check the brackets elements that they are put it in the correct position and within the correct characters. So for our task, I'm just removing this part, and I'm showing that this opening and closing brackets, they are put it correctly. That's why this is okay. This is not okay. We can write, so let it be like this. We can write such like expression. We cannot write such like expression. So this one is also correct. Okay, this one is also correct. So this one is also correct because we can write the nested parentheses inside of this. So there might be the on anything else out in the first section, in the second section, and in the section, it doesn't matter. So this means, so we know that mathematically this expression is correct. So if I'm starting from this one, so let it be like this. I'm opening and closing, and after that, one time I'm closing. This one is not correct because this one is, so the last closing parenthesis is just wrong one, because we don't have any pair for this. So we don't have any pair for removing it. So the task is you are given one line. You have to print out yes or no depending on the color, depending on the characters and the positions of that characters. So I think that the task is clear to everyone. So we want to just start. Solving it. So what we have the one string. So let's get this string, and after that we have to just identify how we can solve this problem. So we can solve it like using the different versions. So we have the many versions of the solutions. So the solutions might be in the difference by the, so we have the 13 students here. Okay. So there might be the different solutions. So one of the simplest one, which is the first thinking one, suggests counting how many elements we have, how many opening parentheses we have, and how many closing parentheses we have. For instance, here we have 1, 2 opening parentheses. Here we have the 1, 2 closing parentheses, and we can just check it. So if they are equal, in that case, you can just print out yes or not. But that solution will not work for this example. Why? Because we have here opening and closing parentheses 1, 1, which are equal, but logically this one is not correct. For these situations, our solution will not work. So again, so in the last example, so for instance, for this one, our solution works. For this one also works. So the first one also works. So this one is not working for our solution. Last one, so 1 opening parentheses and 2 closing parentheses. For this example, our solution also works. Why? Because we have here, we're just comparing how many we have the opening parentheses and how many we have the closing parentheses. They are the different, that's why it will be the false. So let's write our first solution. So first solution, what we want to do, we want to just check how many elements we have. For checking, we want to create the counter, so the CNT, and we want to loop over our string. So we want to start from 0. We want to work until the S size. So S is our string, and getting the 1 by 1 elements, which means SI, it's a current element. So I'm checking if current element is equals to opening parentheses. So in that case, I want to just increment the value of the counter. So which means that initially it was a 0. So if I'm watching the opening parentheses, in that case, I want to increase it. Else if, so again, else. So what does it mean else? Else means we have here the closing parentheses. So we are guaranteed that we have only the 2 characters. That's why else part will be only always the closing parentheses. That's why, so let's put here the parent brackets for more clarification. So in the else part, we want to decrease it. So this counter will be decreased. How do you think what will be the result of the CNT for this input? For instance, CNT initially is 0. By our logic, we are saying if we have found opening parentheses, in that case, we want to increase. So 1, 2, CNT becomes as a 2. Here we have 3. And again, this character goes to the else part, which means minus minus, CNT becomes 2. Here we have 1, here we have 0. After the for loop, I'm just checking if our CNT equals to the 0. In that case, I want to print out yes. So else, which means something else. It might be the more than or less than CNT. So the cout no. So let's check it. So this one is third example. So let's check it. Very simple one, which says yes, this is correct. This one, which is a third example, which is also yes. 1, 2, 3, 1, 2, 3, which is also yes, correct. And last one. opening, closing, and closing one, which says no. No is correct. Why? Because I'm just showing that CNT becomes here for the first character CNT becomes 1, and for next character CNT becomes 0, and here we have -1. So that's why. So you can just see out the CNT here and see the result. So handle. For instance, here we have the CNT 0. For this, we have also CNT 0. For this one, CNT becomes a -1. For instance, for this one, CNT becomes a -2. And for opposite one, for instance, you are opening the 2 parentheses and closing only 1. In that case, CNT becomes a 1. If you are opening the many parentheses but not closing them, in that case, CNT also becomes as a something but not 0. So our solution works for some tests. So which means we have the partial solution, but for this case, if you check your code, third example. So for this case, it says again the yes. Why? Because we have here the one closing and 1 opening parenthesis, which is also correct by our logic, but we have to think about it. How can we solve this problem for our logic? How can we extend our program to identify the such like cases? For instance, if you are opening parentheses and not correctly closing them, in that case, our program identifies that this one is incorrect. For all other cases, it works, but it will not work if and only if we are starting from the closing one. So if I am starting from the closing parenthesis, so in that case, it will be immediately. So it cannot be correct. It cannot be counted yes if I am starting from the closing parenthesis, because you cannot close the parenthesis without opening it. Okay, that's why. So what does it mean? So this one is our input, and our input here. So we are taking the 1 by 1 characters. So which means first character, which is a closing one, and I'm checking here if it's opening, which means closing one goes to this part, to the else part. And inside of the else part, CNT as the initial, it was a 0. I'm seeing the closing one, which is CNT should be decreased, which means CNT becomes as a -1, because we are just starting from the closing parenthesis. So that's why I'm checking here. I have to check here if CNT becomes less than 0. In that case, I can guarantee that CNT cannot be less than 0 in the else part, because if it's else inside of the else part, if CNT is less than 0, in that case, our string starts from the closing parenthesis. In that case, you can immediately see out no. See out no, and return the program. Which means there is no need to check. There is no need to check if we are starting from the closing parenthesis. So I'm checking here for this situation. So if CNT becomes as a less than 0, which means CNT was a 0, and it goes to the else part, and CNT becomes a -1. In that case, I'm immediately showing the no. So let's check it. For the simple ones, it says yes. So this one is not correct because we have the 1 extra closing parenthesis. So our goal is to identify this one. This one is no, as you can see. It doesn't matter how many closing and opening parentheses you have. It should be the no because we are starting from the closing one. Okay. Okay. if you have questions, please guys who are online here, you can ask them for now. Other guys, you can discuss it in the practice lesson or in the direct message with me. Guys, please, your questions for this problem. So any questions?
No.
Okay. So I think everything is clear.
I have a question.
Yeah.
Can you check this for opening and 2 times closing?
Okay. Opening and 2 times closing. Which says no. Why? Because I'm checking that. So while I'm opening the parenthesis, our CNT becomes as a 1. And closing it goes to the else part and it becomes as a 0. For the next time, it becomes as a less than 0, which means CNT will be the less than 0 if and only if we have the more closing parentheses than the opening. Okay. For instance, for this input, we have the 3 closing parentheses and 2 opening parentheses. Again, here we have 2 closing parentheses, 1 opening parenthesis. That's why for this example and for this example, our CNT becomes as a minus value. For instance, for this example, our CNT will be the positive value. So this will be removed and CNT becomes as a 2, positive value. Okay. CNT, it's just a 1 variable. At the end, it will be the 0 if everything is okay. Or it will be the more than 0 if opening parentheses more than the closing ones. And the last case, it will be the negative value if the closing parentheses are more than the opening ones. Okay. Okay. So I think this one is clear to everyone, and I want to continue and extend this example. So the example is the same. So example is the same, but we have the little bit complex task, which means we have here the other 2 types. So the curly brackets. So as you can see from your mathematical expressions, so in mathematical expressions, there might be any types of the parentheses. It might be the square brackets, it might be the curly brackets, it doesn't matter. So for this example, we have the curly brackets again. For instance, here we have the curly brackets like this, which is also yes. So the curly brackets might be here like this, which is also yes. So this one is not. So for instance, this one is not correct. And let's start. So let's start here with using the curly brackets. So here I have the also incorrect solution because we are starting from the curly brackets, which is also no. So our task is for this problem, you are given again the one string which consists 4 types of the characters: opening parentheses and closing parentheses, opening curly brackets and closing curly brackets. And your task is to identify, is it a correct expression or not? And depending on that, you have to print out yes or no. So the solution, so you can guess, and the solution will be the same. You can take this logic, and do it for the curly brackets concurrently in the same time. So in the same time, you can think about it like a CNT will be for the parentheses, and CNT2 will be for the curly brackets. If you are seeing the curly brackets in that, so parentheses, in that case, CNT will be increased. else if you are seeing the opening curly brackets, let's take this one. If you are seeing the opening curly brackets, in that case CNT2 will be increased. Else part, inside of the else part there might be the two cases. So the current character might be closing parenthesis, or it might be the closing curly brackets, and depending on that you have to just do the actions. So you can again do it like this. Okay. Inside of the else part, so if it's the opening one, we're increasing the CNT. If it's opening curly brackets, in that case we are increasing the second counter. So if SI equals to closing parenthesis, in that case I'm doing the decrease for the counter of this one. So inside of the else part, so this else part means SI or closing parenthesis or closing curly brackets. So inside of the else part, it might be the closing this one or this one, and depending on that you have to do the actions. So if it's a closing parenthesis, you have to work with the CNT, and you can just copy it. And if it's a closing curly brackets, in that case it will be using the CNT2. So at the end you have to check CNT should be equals to the 0 and CNT2 should be equals to the 0. So you are just doubling the current logic for the two items. So the V2, which is yes, which is no, which is also yes, which is yes. Okay, this one is just a solution for this problem, which is a more complex one. So you can extend this example and you can add the square brackets, and this one is for your homework. So please try to solve the problem when you have the 3 elements. So which means the square brackets again. So I think this one is clear to everyone, because it's just an extension of the first one, which was clear to everyone. So for now, I want to show the same example. So not same example, it's just the first example from here. So when we have only the one types of the parentheses without any curly brackets. So this task, so the current task, and we want to solve. So why I'm solving this problem in the title of the stack? Because we want to solve this problem using the stack. So the problem is the same, and our task is to identify is it the correct expression or not. Okay. What we want to do, we want to remove everything here. So we want to remove everything here. And what we have the string, we have to read it. So, sorry. So we already read. So we don't need any CNT because we want to solve it using the stack. And for that, we want to create a stack. So let's solve it inside of this one. So let's imagine that this this vertical box is our stack. Our stack which can hold only one character as an element. So what we want to do, we want to take this this stack as our CNT from these first examples. So CNT was just like an integer, which is a 0 at the initial point, and it might be the increased and decreased depending on the character. So here we have the same logic. So we want to use our stack, which will hold one character. So that's why here we have the char as a value. So our S is here, which can hold characters. So let's take the first example. So as we did before, so it'll be like a box. As we did before, our box is here. So I'm checking that the current character is opening one. So the opening parenthesis. In that case, I'm putting it to the stack. So opening parenthesis over here as a character like this. As a character, this added to the stack. After that, I'm taking the next character, and if the current character is not the opening one, so it means it's a closing one. So which means it's the else part. So if it's the opening one, I'm here increasing it. But we want to do the same thing, but let's copy this one and put it over here. If I am identifying that the current character is opening parenthesis, in that case, I want to push the data, push the SI, push the SI to the box, which means I'm putting this opening parenthesis over here. Next character, it's a closing one. If it's a closing one, it goes to the else part. Inside of the else part, I want to, from the box, I want to pop it, which means I'm just added one character here, and inside of the else part, if it's a closing parenthesis, in that case, I want to remove it. And after removing, at the end, I want to just check, is our stack is empty? If our box is empty, in that case, I want to print out yes, so which means there is no error, and this expression is correct. Otherwise, this expression is not correct. Let's check it. Free and free. So opening and closing, opening, closing. It says yes. 2 times opening, 2 times closing. Again, yes. 1, 2, 3, 1, 2, 3. Yes. 1, 2. 1 times I'm closing. This one not correct. Why? Because let's imagine here. So I'm seeing opening parenthesis. I'm putting it over here. I'm seeing again opening parenthesis over here. I have here closing one. While closing, I'm just removing the last added element, which means this will be removed. And that's it. As you can see, our stack is not empty. That's why it should go to the else part, and it says, oops, sorry, I have to write over here. So it goes to the else part. So it goes to the else part over here because our stack is not empty, and it says no. But for the example that was a problem from the first example, which is from the starting point, from the starting example, if I'm putting the closing one, in that case, it cannot be executed. Why? Because it will immediately goes to the else part. Starting from the first character, it goes to the else part, which will try to pop from the stack, but stack is empty. Pop function should be called if and only if we have the elements inside of the stack. So that's why I'm checking here if our box is empty, which means we don't have any elements inside of the stack, but we are trying to pop it. If our box is empty in that case, and I'm located inside of the else part. Else part means we have the closing parenthesis. And if it's empty again, I want to see out no and return it. Why? Because if I'm inside of the else part, which means current character is closing parenthesis. And if it's a closing parenthesis, there should be already added opening one inside of the stack. But inside of the else, we might have the empty stack, which is in these situations. This situation says closing one goes to the else part, and it tries to pop inside of the stack. This one will not work because we don't have any elements inside it. And that's why it cannot be identified. So let's compile it again. For simple ones, it works. For this one also it works. For this one also works. So let's compare the first example and this one. In first example, we are using just CNT as an integer, which will be just increased and decreased. Values that will be increased and decreased. In this example, we are using instead of the integer one, we are using the stack, which will hold the characters inside it. If it's an opening one, we are adding to the stack if and only if the current character is opening parenthesis. So the opening parenthesis here, I'm pushing it. If it's the else part, which means closing one, in that case, I'm just checking if it's empty, no, which means the user starts from the closing parenthesis. Otherwise, I'm just removing it from removing the last added element to the stack, which means this one will be removed. And at the end, I'm just checking, is our stack is empty? If it's empty, everything is correct. If it's not empty, in that case, there might be the problem. So, and your task is okay. Let's implement the solution for this one. Solution for this one using the stack. I want to show with you. I want to discuss with you online, and I think the example for the 3.5. I'm going to remove everything here. So example for the using the square brackets. Square brackets will be your homework. So let's remove everything here. Your solution here. So this one will be your homework. For now, I want to show the solution using the stack for the two types of the characters. So again, the task is clear to everyone. So the problem is the same, but there might be not only the parentheses, so there might be the curly brackets again, and I have to solve the problem. So, okay. What we want to do, we want to implement this one. So let's remove this or stack. So the logic should be the same as we did in using the simple CNTs. So inside of the simple ones, so we just created the two counters. First one for the parentheses, second one for the curly brackets. But if you have the many characters, so if you don't know how many characters you have, in that case, you cannot create the number of variables for counting the elements and so on. But for the stack, so you can store any elements, you can store any number of elements inside of the stack. It doesn't matter how many different values you will have. So what we want to do, we want to identify the opening elements. So it might be the opening parentheses, it might be the opening curly brackets. It doesn't matter. Any of these two characters, if I am getting this one as a current one, in that case, I want to push it. So as you can see here, I have the push only if the opening parentheses. And I'm putting here or if SI equals to the opening curly brackets, in that case, I want to again push it. So let's again, so I think this one will be clear. So if I am seeing that the current character is one of these opening elements, in that case, I'm pushing it. In the else part, else part means we are identified that we are somehow, so in this case, we are somehow identified that the current character is the closing ones. So the SI here, this one or this one. So let's create the character which is the current one. So the current character, it's one of these two characters. It's a closing parenthesis or closing curly brackets. Okay, what I want to do, let's take the first example. Inside of the first example, we have the opening parenthesis. So I'm putting it to the stack. Opening curly brackets, I am putting it to the stack. And here I have the closing curly brackets. And what I have to do, I have to take this curly brackets closing one and check from the top element of the stack. So for instance, if we have here like this becomes as a no. Why? For instance, even we have here such like a correct number of characters. So here I have the two opening parentheses and two closing parentheses. One opening curly brackets and one closing curly brackets. So the numbers are the correct, but result is no. Why? Because this expression is not valid. So if you are opening the curly brackets, if you are opening the parentheses, in that case, you have to close it using the parentheses. You cannot close it with using the curly brackets. So that's why. So the first two elements, as they are opening ones, we are putting them here. And again, we have here the opening parentheses. I'm putting it over here. And here I have the closing one. Closing element, it doesn't matter. So that for us, it's a current. So current, let's imagine we have here the closing curly brackets. And what I have to do, I have to compare the current element using the last added element to the stack. Last added element is this one. So let's take the last added element from the stack. Let's create the char. So the last added. Last added, I want to take from the box. I want to take the pop. Oh, sorry, top. So the top returns the last added element, which is in our case the opening parentheses. So after that, after getting the current character, it might be the one of these two, and last added will be the one of the two opposite ones. So I have to check if current character is equals to closing parentheses and it will be like this. Last added element is not equal to the opening one. So what does it mean? If the current character, so the current character is, so let's start from the curly brackets. So if it's a current character like this. So in our case, current character is closing curly brackets. So the current character is closing curly brackets. Last added in our case, opening parentheses. So this one. And I'm checking if the current character is this one and last added is not equal, as you can see, not equal to this one. In that case, I have to stop it. I have to see out no and return it. So the same thing for the parentheses. So if it's closing parentheses and last added was not closing, so the not opening parentheses, in that case again will be the no. No, and print them out. So if these two ifs are not working, so which means they are the correct. So which means everything is correct, and after that I can remove the last element from the stack. And after that, the logic will be the same. If the box is empty, in that case, yes or no. So let's see the result. So let's check it. So the simple ones, which is yes, which is no. So we forgot about this case when we have the one closing element. So the closing element, and we are trying to get the data from the stack. So which means I have to check it over here. If we are inside of the else part, which means we are getting the current closing character, it doesn't matter which one, we have the closing one. Inside of the closing character, we want to remove the element inside it, but I have to check it. If our box is empty, so in that case, I have to again see out no and return it. Why? Because we cannot remove the data from the empty stack. So like this, closing element, it should be no. This one also no. Why? Because we have here opening one, closing one, which is correct. And our stack is empty. And we have here the closing one. And inside of the closing, we added this expression, which will check if the stack is empty. In that case, we have to stop it. So let's take the first example. First example says this part is not correct, that's why it's a no. If you're adding it like this, so in that case it should be the yes. Why? Because these two parts will be removed, and these two parts will be removed, and these two parts. So let's put this example to the examples here as a yes. So let's see this example here. So the opening, and opening here. So all opening characters was added to the stack. And after that, one by one, I'm getting the closing characters. So the closing characters here, closing parentheses, and I'm checking. If the current character is closing and last added also opening, in that case, this character will be removed. Next element, we have here closing curly brackets. Again, if you have the closing curly brackets and last added is not equals to the opening curly brackets, but inside of the stack we have opening curly brackets, which means it will just pop it. You will have the pop, which means this will be removed. And the last element here we have the closing parentheses, and this one will be removed. And after that, box becomes as an empty, and after that cout yes, which is correct. Okay, so for the solution, which was over here using the CNTs, you cannot identify the such lucky cases. For instance, for this case, it says yes. Why? Because we have here CNTs for the two types of the parentheses brackets. So CNT for the first one says 1, 2, and it becomes 1 and 0. When we have the closing ones, we are just decreasing. We are just decreasing them. And CNT1 will be equals to the 0. And for the CNT2 also will be the 0 because we have here the opening one and the closing one, but we don't identify the location of them. Okay, so the sequence or sequence of the putting these brackets we are not identifying using the CNT's example. Okay, but this solution automatically solved inside of the stack example. Inside of the stack example, using the last, just like these comparisons. So the last added element to the stack should be the pair of the current one. If it's a not pair, in that case, we want to print out no. So as you can see, we have here the return no, return no's. You can take these two examples and put it like this and put or between them and put inside of the one condition. Yes, or this one or this one. If any of these conditions will be executed, in that case, you have to see out no. Okay. So I think this one is clear, and your task is to implement this one for the next example. So how many students were? 13. Okay, I think this one is. So recording is going. Okay, so we want to continue the fourth example and continue and show the simple, so the brackets validation, simple explanation of the queue. So about the queue we already discussed. So by the name, you can understand that the collection will store the data like a queue from the real life. It's a queue of some people in the consuming the reception. It might be the anything. So the queue, for using the queue, you have to import the library. The library also called the queue. Creation of the queue will be the same as before, as our previous collections. So the queue, integer, and queue. And for the functions will be almost the same as before. For adding the data, you have to use a push. So the pushing some data to the queue. So the 10 ought to be the 5 and 7. So queue will be like this in vertical side, vertical collection. Pushing the free, which means the person with the ID free comes here. Free becomes in the first position as the first consumer and first executable person. Comes 10, person with ID 10 goes here. Comes 5 and comes 7. And all new coming persons, sorry, new coming people will be added here, one by one to the end of the queue. So the functions that can be useful and can be used for solving any other problems, they are the same. So the size, so again the empty, and adding the data, clearing, and so on, everything else. So the empty is also one of the functions. So what else? So we have here, we can identify the front of the queue. Oh, sorry. So the front of the queue, which means number 3. Number 3, so to identify the which person will be executed now. In that case, you can call the function front, which will return the first. So the logic of the queue is the FIFO. Sorry, FIFO, which means first in, first out. Who comes first to the queue, that person will be executed again first. So to identify the current executable person, you can call the function front, which will return the current element. For instance, if you are popping the data from the queue, which means pop means the first executable person was consumed, and this number will be removed from the queue, which means number 3 already finished discussing the problem with the reception. And who is the next? So I'm removing the first element, and who is the next? It's the next element is 10, which is a person with ID number 10 comes to the queue, and the next element will be that person. So the pop again will remove the first element by this strategy, and front will return the next executable person. And we have the opposite one, which is a back. Back, by the name, it can be clear that the last added element to the queue. So not first one, but the last element from the queue. Okay. So for looping over, again, you can use a while loop. So queue is not empty. If it's not empty, so counting front of the element. Just close the empty this one. So if it's not empty, show the front element, and after showing, remove it. And that's it for CPP. And if you run it, you will have this such like a list. So 3, 10, 5, and 7, which is the 1 by 1 by the adding of the first added person, as you can see, executed first. Second added person executed second, and so on. And this is the logic of this, the logic of the queue. So the queue and stack, they can be implemented by yourself, so you can create your own functions, so you can create your own data structure, and the data structure can be named any, it can be set at any name, and you can do the same logic using the vectors. But for you, there is already created library like a queue, but by the definition, so by the definition, you can understand that this one is just a simple strategy, and these expressions can be implemented by yourself. So there might be this such like expression, such like a question. So question says, so you have you can use only the vector, but you have to implement the strategy of the queue. The next problem, you have you can use the vector, but you have to implement the logic of the stack. So let's try to implement such like problems at your home as a laboratory work. Try to implement the functions, because you can already create your own functions. So the function says, I want to add something and close, so that I want to add some data to the stack, but you cannot use the existing stack. You have to implement it by the vector. So such like problems might be in the final exams, in the end-term exams, and so on. So the queue, pushing element, empty size, front, back, and pop. So the next element will be, so the next example will be for the queue. So, okay, like this. It's a DQ. So the DQ also the same. So same library like a queue and like a stack. So the same, not library, it's just a collection. So the DQ, it's a collection that can be just like it's just an extension of or mutation of the queue. So it stands for double-ended queue. So which means D, E, and Q. So here I have the deque, as you can see, the deque, and also known as dec. So deque is just a pronunciation from us, like an English word, but in the programming C++, so the deque also called like a dec. So we have a dec. Dec stands for the double-ended queue. What does it mean? So the strategy of the and logic of the queue we already know, which is a first in, first out. We have the such like a vertical, not vertical, it's a horizontal box, in which we can add the data. So let's create a deque. Deque will be the same. The creation of the variable will be the same, but we have here, as you can see, the double-ended queue. What does it mean? In the previous example, we have the queue, and inside of the queue, we have only the one end position. Where is the end position? End position over here. End of the queue. Here we have the reception. So here I have the reception, and here I have the end of the queue. It's a head of the queue. It's a tail of the queue. It's just a simple queue. But inside of the deque says we have the double end, which means here I have the reception, and it doesn't matter. For the deque, this part can be the head, and in the same time it can be the tail. For this part also will be the same thing. What does it mean? It means using the deque, you can push the elements from the both sides. So push front means, so we want to add the, for instance, number 4. So in this case, push front means push back. Let's start from the pushback. Pushback 4, which means 4 added over here. And I'm adding the push front, adding the 3. So which means push front means even we have here the 4 as the first position of the queue, but we are pushing the front side, front element, which means 3 becomes before the 4. Okay, so this is the logic of the deque. So you can add the elements from the both sides. So if you are adding the again push, for instance, 5 here, so the 5 becomes element of the first element of the queue. Reception is over here. For instance, pushback. So pushback, if you remember, this function was inside of the vector, but vector cannot add the push front. It can add only from the backside. But the deque, it's just a combination of the queue and vector. It's just a mix of the queue and vector. But the logic is the same as like a queue. So you can add from the both sides. It's the first ability and first difference. And the second one, you can get the data from the both sides. Pop front. So before the pop fronting, I want to show pop front, queue front. So what does it mean, queue front? So that will be this 8. 8 will be inside of this one. So deque, we have here the deque, and we want to get a front element. Front element is 5. Front element respecting to the reception. Reception is over here, and the front element, which is a person who will be executed and who will be consumed now. For identifying such like a person, you can call the function front, which is number 5. And in the same time, let's put space here and queue back. As you can see, 8 is a back element inside of the deque. for now, this one is already clear to everyone, but we have here the option for removing from the both sides. For instance, if I'm removing from the front, so 5 will be removed and front becomes number 3. If you run it, front becomes number 3 and back number 8. And you can do like back side also. You can remove from the back side again. As you can see, the back side 8 was removed and the last element becomes as a 4. First element becomes as a 3. So the strategy of the queue, which is a first in, first out, will not work inside of the dequeue. So dequeue, it's by the name says double-ended queue, which means the queue gives you ability to add and remove the elements from the both sides of the queue. Okay, this one is just the logic of the queue, and if we have inside of the problem, so during the end term example, so exams or final exams, if we have the problem statement, and if problem statement says you have to use a dequeue, in that case you can use it. Or if it's not mentioned, so if it's not mentioned in the statement of the problem that you have to use some of the collections, in that case it's up to you. Any of the solutions will be acceptable and it might be anything else. So pay attention to the statements of the problem and requirements. If requirement says you have to use a queue, in that case you have to solve this problem using the queue. If it's a stack, you have to solve it using the stack. If says you cannot use, for instance, in some problems it might say it like this. So the problem explained somehow. So the problem will be explained somehow, and it says you cannot use the stack. So problem might be easier to solve using the stack, and the problem set says you cannot use it. So such like problems, if you are doing the restrictions of the problem statement, in that case you will lose your points. That's why pay attention and try to read the problem statement correctly and solve the problems. Okay, so any questions for now, guys, who are online? I have 11, so the 10 students. So this was the last title which we have to talk today, which we have to finish today. It's time to your questions. It's time to your questions. As you can see, we have here the 2 weeks. So the 2, not weeks, it's just lectures. Lecture number 10. In the next week, we will discuss, so in this week, and the Saturday, we will discuss about the algorithms. So just extra functions that can be used for the problems. So these functions also already implemented, and you can implement it by yourself, and we'll show it. And last lecture will be about the pointers and struct. About the struct and pointers. And that's it. Okay, questions, guys? Dina, please.
Can you open for CPP?
Oh, okay, I can. Yes.
There is after we did empty. Why it print out front if there is no elements in the stack, in the queue?
So can you say the line? So are saying about the 28th line?
24 and 29.
24. 24, which is commented. Commented
Oh,
says,
sorry, 22.
Okay, 22. So this empty, it's not a clear. So you are mixing so you are just thinking about this function, which is not available for the queue. You cannot clear it. So empty, it will not change the content of your queue. It's just a Boolean function which will identify is your queue empty or not. It will return 0 or 1. Okay. it will just identify, it's just a Boolean function. It will return just a 0 or 1. It will return 1 if you have at least one element. It will return the 0 if you have, if you have at least one element, it says it's not empty and it's a false. And if you remove these lines, which means your queue is empty, and empty returns 1, which is true. And now here we are just showing the size, which is number 4. So let's run this code again. So the size is 4. QEmpty, which is a Boolean function, will say 0. Why? Because we have elements inside of the queue. An empty function, which is a Boolean, says 0, which is false, which says this queue is not empty. That's why it's false. And after that, I'm just showing the elements one by one while this queue is not empty. After removing the last element, which is number 7, after removing the last element, after removing just using the pop function, after removing the 7, queue becomes as empty, and while loop will stop working. Okay, Dina, is it clear?
Yeah, I see. Thank you.
Okay, any other questions, guys? So questions might be in any language, guys. Don't be shy. If you have questions, you can ask in any language. Okay, so let's add these examples to the GitHub. So, so while you are thinking about your questions, so I want to edit. So this one is a lecture 9. And here what we have, here we have the stack, here I have the queue, here I have the dequeue. Okay, I want to push it. And you have already your lab work link. You have to solve the problems, all the problems inside of the lab works, and prepare yourself to the end term exam. About the end term exam days and format will be separate posts in the general channel of our group. So inside of the channel will be the announcement about the end term exam and the date of the exam. Okay, and the timetable. Don't mix and check the timetable again and again during the before the end term exam. Okay, so there might be some changes. So we will again announce it inside of the Teams. That's why please be online and check the announcements inside of the general channel. If we have the changes in the timetable of the end term exam, we will announce here. And in that case, you have to check again your timetable and schedule of the exam. Okay. So if you don't have any questions, I already uploaded the examples, which means I can close it. So the syllabus you already have. And it's time to stop the recording.